Welcome back to Rational Functions. At this point in time, through parts 2 and 3, we have learned to analyze rational functions from their equations. We know how to get things like critical values. We can create a sine graph. We know how to get vertical asymptotes. Now we know how to get horizontal asymptotes, as well as points of discontinuity. And from the sine graph, we can also get the zeros of the function. And we know what's involved in finding a y-intercept. Just letting x equal 0, seeing what happens from there. We have all of those tools available. We're going to use those tools to graph these things. I would do it in this order as listed up there. I'd find those critical values, create my sine graph. I'd determine the coordinates of any holes, determine the asymptotes and intercepts, although I should be able to get most of those from the sine graph itself. Plot all those things, draw the curve. So if I'm looking at this, I'm noting that my critical values are -3 and positive and -1. So I can create my sine diagram. Pew, pew, pew. I have x, not y, but f of x, technically. At -3, the f of x is 0. At plus and minus 1, this thing's undefined. This gives us how you say one of the zeros of the function, one of the x-intercepts, or the only x-intercept. To find the y-intercept, we'll find f of 0. And that is equal to 3 over -1 times +1, which is equal to -3. All right, so we have our intercepts, we have our vertical asymptotes, we need our horizontal asymptote. We know highest degree on top is 1. If this is expanded, simplified, that has a degree of 2, so we've got more x's on the bottom than on top. So we have a horizontal asymptote. At y equals 0. And finally, let's check for points of discontinuity. While there is nothing here that could be simplified, there's no holes. This thing is ready to go. Last time we graphed things in this topic, I mentioned make sure you use a ruler because we don't want to say, okay, 1 tick mark, 2 tick mark, 3 tick mark, 4 or 5, 6. That's unevenly spaced. Ugh, gross. Have some sort of measuring device. Just make it look like you tried, you know? So I'm using a ruler here. I'm trying to line it up. Ooh, I'm questioning my skills. No, I'm good. Mad skills. Oh, that's an eraser. Yeah, now I'm questioning my skills for sure. I'm going every ½ centimeter. I mean, I tried this out earlier. There was a failed take of this video. And I tried going every centimeter. And it works. I mean, you can get the whole graph on here. But there's an aspect of the left side that just did not appeal to me. So I'm going every ½ centimeter instead. And I'm hoping that works. As long as I have enough tick marks to fit in every x and y value that I've discovered, everything's really all hunky-dory. Do I have enough tick marks to support my zeros and my asymptotes? Do I have enough to support my intercepts? If yes, then we good. And I'm just gonna take a moment to wait. Oh no. Where's the redo button? Oh wait, I just did this. Ah. Oh, that's a pen. Do I even know what scissors are? Yeah, I'm just going to copy this real quick. No, that's not even what I wanted to do. Now I'm going to copy this real quick. And I'm going to stick it on these other ones so that you don't have to suffer through this every time. You just really have to suffer once. It's a miracle. Paste. Held it. Bloop. All right. Graphing this thing. I'm going to plot my asymptotes. Asymptotes. Why not use red? -1 and 1. Okay. Again, using my trusty ruler. +1. Dun, dun, dun. Dun, dun, dun. Dun, 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 dun. Dun, 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 dun. And horizontal asymptote is the axis itself. Right. Oops. My ruler's a little off. But then so am I, so. Using a pencil on this, just you'll have to make sure you're going extra thick so it's very clear that you put a dotted line there. Just make it evidenced. That line has the equation y = 0. What else can we plot on this? I know. Let's plot our intercepts. We have this when x is -3, y is 0. Okay. So that's this point right here. And we have a y-intercept when y is -3. Cute. All right. It's probably a good idea for us to actually finish off this sign diagram because Captain Genius over here did not. So our pluses and our minuses. On the very right-hand side, you should be able to figure out that this whole thing is positive. And then, since the critical values all have odd multiplicity, it's going to switch every time. There aren't a ton of dots on here, but there's enough for us to figure out what's going on. Like between these asymptotes, this function stays negative. That's this section here. So I'm just going to make sure it stays negative, but trends towards its asymptotes. Boom. What happens to the left of that? Well, it's positive for a bit. So coming out of here, it's going to come out of the positive end of this asymptote. Not from this negative end, because, again, it's positive right here. So it's going to come through that positive end, and it's going to reach a 0. So that's what it's going to do. It's going to come out of positive land over here. And then it's going to hit this 0. Now, as it hits that 0, is it going to cut through? Is it going to wiggle through? Or is it going to bounce back? Well, it switches from positive to negative, so it goes through somehow. And it's just a multiplicity of 1, so it's just a cut through. Just like with polynomial functions. So it cuts through. What happens after that? What happens in this area? It stays negative, but it trends towards the asymptote. So even though it's gone into negative land, it's going to be like, whoa, I don't want to get too far from that asymptote. I'm going to come back here and then just live the rest of my days trying to hug it real close. Ooh, I'm missing an arrowhead. Should probably fill that in. Boom. Missing? No, it's not. On the other side, so this whole region here, it's all positive. Okay. We don't really have any points, but being all positive, we know it has to come out of this area right up there. It can't come from down here. That's negative. So it comes out of positive land. Where does it go from there? Well, it doesn't have a whole lot of options. But it's definitely not going to cross over this axis. As x goes on forever and ever towards infinity, this thing is going to try and hug its asymptote. So it's just necessary that you show that asymptotic behavior. That you show that it's trying to hug it close. Make sure you label all, how you say, the axes and scale. Axes are labeled. Scale is not labeled. That should probably get thrown in. So this is like 3. This can be 1. And that's that. Don't forget, we've used Desmos a few times. If you want to check your work as you're doing practice work, I would absolutely recommend using Desmos. Like, sure, yeah, there's textbook answers too, but just use it. It's a very handy calculator. Or if you're absolutely stuck, you can use it. It's helpful. Can you use it during an exam? Like if we had a provincial exam this year, then no. But it's a useful graphing calculator, regardless. Anyways, we're going to graph another one. Ooh, this one's got a few more critical values. That's exciting. Does not have this dot there. Did I keep the dot there? Oh my goodness. Perfect. But the process is the same. I'm going to make myself a sign diagram. I'm going to use all this valuable space down here. Look at that. It's blank canvas. World's my oyster. What are my critical values? I don't even know. Critical values are plus minus 1, 2, negative 4. X, and what are we dealing with? F of x again? Wicked. F of x. I've got 4 critical values. Ooh. Lowest of which was negative 4, negative 1, and 1, then 2. This one makes things undefined. Everything else was 0. Neat. On the right hand side, if x is 1,000,000, that's positive, 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 positive. Okay, so this whole thing is positive. And it looks like this will switch every time except when you have an x value of 1 because of that multiplicity. So it switches, it stays same, it switches, it switches. Neat. Okay, what else do I need here? I need to figure out horizontal asymptote. If this was expanded and simplified, top would have a degree of 3, x times x times x. Bottom would have a degree of 2. So we've got more on top than bottom. Well, I guess we don't have a horizontal asymptote. And last thing, we need to figure out if there's a y-intercept. What is f of 0? And why am I that far over? Nice little mysteries. So the y-intercept, f of 0 is 0 plus 1 is 1. 0 minus 2 is negative 2. 0 plus 4 is 4. And on the bottom, we have 0 minus 1 squared. Okay. Calculating that, looks like we get ourselves negative 8. Oh, I did label it there. Thank goodness. All right. Well, let's get to it. You know what? I'm not going to use this scale that I have for the y values. Because -8 is like way down here. It's just, I don't like having to draw stuff at the extremes of this graph. So, that's that. So I'm erasing that. Okay. I plot my zeros. No, I plot my asymptotes. You know me. Where do I have one? When x is 1, because of that. That's my only asymptote. I plot my zeros at -4, -1, and 2. Neat. I should plot this y-intercept at some point, but this is where I'm using my trick of I'm just not gonna indicate my scale there yet. I'm not gonna draw my tick marks. I'm just gonna follow the sine diagram. I'm gonna start around this asymptote. I'm going to start on the right-hand side. So on the right of 1, this thing's negative. So, okay, we're coming up from down here. And we're going to come up and through this 2. Ta-da! And then as we go through, does it go towards an asymptote? Does it go back towards the axis? No. There is no horizontal asymptote. So it's just gonna like keep doing its curve thing. It's gonna just live its happy life. That's what it does. Next, so like we've checked off this and this. Let's go over here. It's negative. So again, we're coming out of negative land over here. And we're going to reach that 0. We are going to then go into positive land. Okay, so it goes through. And from positive land, we need to hit this 0 again. And then it becomes negative. Becomes negative. And then just goes there forever. At some point, we have to indicate the scale. So this can be like 4. I bragged about not indicating my, how you say, y-axis scale. But this is just so I can draw the graph nicely and say, oh, you know what? Here's where it went through. That's -8. I mean, it's a good thing it went through the negative side. Otherwise, I would have known I drew it wrong, incorrectly. But we good. We good. One more example of this, and it is a doozy. That's right. That's the word of the day. You guessed it. We're going to handle this doozy. And you know what? Once again, I'm just going to get rid of this whole, the dotted lines for my y-axis. And just focus where my heart lies. We have got a bunch of critical values. But there are interesting things that happen. If we look at this, there's an x minus 2 on top and x minus 2 on the bottom. Boom. Boom. It's still a critical value, like a value we need to concern ourselves with. But it kind of reduces the magnitude of this function. And we have an x minus 1 here and here. Now on top it's squared. So we can get rid of this if we get rid of that. So this isn't really the worst thing in the entire world. There's still a lot of critical values. But again, this could be way worse. So we're dealing with critical values of -6, 3, 1. I'm going to keep that 2 there, even though we slashed it out, because it's something we need to pay attention to. We've also got -2 and +6. It's a lot of critical values. How many did I have? Why can't I scroll on this anymore? Alright. 1, 2, 3, 4, 5, 6. 6 critical values. 1, 2, 3, 4, 5, 6. Lowest of which was -6, -2, and then 1, 2, 3. I can fill in what happens at each of those that I know. I'm going to ignore the holes. There's a hole here, there's a hole here. Ignore those for now. And just say -6 comes from the top, so that's a 0. -2 comes from the bottom. That gives us something undefined. 3 comes from the top. That's a 0. And 6 comes from the bottom. Undefined. Knowing that those holes exist, I'm going to figure them out right away. So, as x approaches 1, f of x approaches, well, whatever is left here. So plugging in 1 for all those remaining things on the top. Oh, check this out. On the top, so we'd have 8 times 7 times whatever, like -2 squared times 0. And then on the bottom, 1 plus 2 is 3, and this is -5. But this whole product up here is 0. Look at that. Just dangling there. So, alright, f of 1 is 0. It would be 0. Darn hole. The other hole, oh wait, so this is approaching, this is a hole, and this is a hole. But as x approaches 2, what does f of x become? Well, let's go back here. This would be 8, x minus 3 is -1. X minus 1 is -1. Nope. 2 minus 1 is +1 these days. On the bottom, we would have 4 cubed times -4. Okay. So calculating that, top we've got 64. Bottom we've got, well, this is 64 right here. So I guess 64 times -4. That's my scrap work, in case you weren't sure, but that reduces -1/4. Bam. So those are my holes. What else do I need? I need to get my horizontal asymptote. Okay. Let's look at what's remaining here. Degree of the top is 1, 2, 3, 4. Degree of the bottom is 1, 2, 3, 4. Woo! Same degree top and bottom, which means we're going to have to figure out that leading coefficient. Well, it's just 8 times 1 times 1 squared times 1 on the top, and on the bottom it's just 1 cubed times 1. Just looking at the leading coefficients of each of those terms. So, I can say that my horizontal asymptote is there. And last bit of business. Oh, intercept. I need my y-intercept. Which is 8 times 6 times negative 3 squared times negative 1. And on the bottom, we've got a 2 cubed and a negative 6. Neat. And that equals something. And there's stuff that cancels. 8 and 2 cubed, 6 and negative 1 and negative 6. So okay, so this works out to 9. Woo! Oh, I'm exhausted. Not even done. I can do this. I'm strong. I am mighty. All right, I am drawing things. I'm gonna get my asymptote. Where are we going? Negative 2. And positive 6. 1, 2, 3, 4, 5, 6. Well, I am going to have a tick mark for where, how you say. I'm going to have to draw where the y-intercept is. And I'm going to have to draw that horizontal asymptote eventually. I'm going to hold off a bit until after I just draw this whole middle section. So I'll figure out what's going on here. And then when I get to the outsides, that's when I'll draw my horizontal asymptote. What else do I need here? I need a 0 at negative 6. 3, 4, 5, 6. I need a 0 when x is 3. I'm going to ignore the holes for a little bit. Ooh, I need to complete this sine diagram. Were you positive on the very right? And figure out how things go. Over 6, it switches. Over 3, it stays same. Over 2, it stays same. Over 1, it switches. Over negative 2, it switches. And over that, it switches. Okay. 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 Normally, over here, there would be a value of 0. So we do have a little bit of a hole there. And then there's a hole like at negative 1/4, or when x is 2, y is negative 1/4. So somewhere like around here-ish, I don't know where exactly. I'll draw it after. I do know that this thing's negative at that point. Okay, so I can do a little connect the dots like that. And then it hits 3 at 0. That's this over here. And then it goes negative again. And at that point, it goes negative until it reaches that asymptote. So that's where we're at. And what else are we looking at? This section here is positive. So it goes up. And does that. I did mention I was going to draw that hole later. So I'm just going to fill that in. It should be right here. That's at the point 2, -1/4. So indicate what that hole is. All right, how about the rest of this? Well, I'm just going to quickly indicate that this is 9, because that's what we found our y-intercept to be. Our horizontal asymptote is at 8, so it's got to be a little less than that. Where's red? Found you. So at this point, I'm going to draw in my horizontal asymptote. It's not perfectly to scale, but it gives us an idea of what this function looks like. It's a little less than 9, that line, so hooray. I'm going to get this section done. Everything to the right of 6 is positive. So positive end of the asymptote up there. And then it's going to try and glue itself to the asymptote here. And then over on this section, to the left of -2, we are negative. Okay, so it comes up from the bottom. It's got to hit this 0 here. So I'll have it do that. And then it stays positive, but trends toward the asymptote. That is generally what this function looks like. If you actually do graph it using technology, you'll find it's ever so slightly different at the ends. It actually cuts through that asymptote before honing in on it, which is kind of neat. But what we get from here is a very good idea as to what this function looks like. It generally looks like this. There would be some very slight differences. Maybe this bump I've drawn here is a bit too big, given where my 9 is. Like, that's definitely not a quarter. But we have an idea. We get a feeling for what this graph looks like. And that's what matters more than anything when you're drawing these relations. There is practice work. Whew! Probably nothing as involved as this last one, which again was a doozy, my goodness. But give it a try, give it a go. And as usual, ask me if you have any questions. It's been a slice. Tell everyone I say hello. Goodbye.